Hey Pre-Cal Mustangs, today we're going to talk about Unit 1, Lesson 2, which is Parent Function Graphs and Transformations. If you haven't had a minute yet to do so, I've got some practice graph paper, looks like this, on my Schoology website. So if you want to, I would highly recommend right now pausing the video and going and printing this out so that you have something to write on, or grabbing a piece of graph paper. Either one, whichever way is better for you. So I'll give you just a minute to pause the video and go take a look at that. Okay, so hopefully you had a chance to print out this piece of paper. This is what I'm going to kind of be working on. So again, parent function graphs and transformations. I'm going to start just by going through the basic parent functions. You probably remember a lot of these from Algebra 2, but just in case you need a refresher, because it's been a while since we saw that, we'll take a look at these parent functions and their graphs real quick. All right, so let's start with our quadratic parent function. So what's special about our quadratic parent function, it's going to make our parabola shape. And to do that, I'm going to start right here at 0, 0 for my parent function. That point's going to be important because once we start the transformations, that's when I'm going to be moving up and down and left and right. And then I want to square my x value. So if I go 1 and square it, I'm going to get 1. And if I go 2 to the right and square it, I'm going to get 4. And let's also go to the left one. So negative 1 squared gives me 1. And negative 2 squared gives me 4 also. And that'll give me my nice parabola shape. The other thing I want to write down on here is how many points I would like for you to draw when you are drawing a parabola. And I would like for you to draw 5 points. We've got 5 good points on there. If I can lock my autofocus real quick. I heard that I can do that. Hang on one second. Yep, there we go. There we go. Okay, that way it'll quit kind of zooming in and out on you. Okay, when we talk about domain and range, we talked a little bit about domain the other day and writing in an interval notation. We're going to use that same interval notation for these as well. So just a refresher that domain means we're talking about the x values and range means we're talking about the y values. So in this case, my x values go all the way this way as it continues to go, and they go all the way this way as it continues to go. So I'm going to have a domain of all real numbers. Remember, in interval notation, we write that like that. So from negative infinity to positive infinity with those parentheses. Now my range is a little different because I noticed that all of my y values are positive in this case. So I'm going to say that I'll start right here at 0, and I can touch 0 on this. So I'm going to use a bracket on 0. And then they go up and up forever, so we can go all the way up to infinity. Okay, so our first parent function of x squared. All right, the next parent function I like to talk about is my absolute value parent function. I like that one because it looks a little bit like the quadratic, so I like to do that one next. I'm also going to draw 5 points on this one. This is the one that comes out as that nice V shape. So whereas the x squared is that U shape or the parabola, this absolute value is going to give you a V shape. I'm still going to start right here at 0, 0. But when I take the absolute value of 1, I get 1. And the absolute value of 2, I get 2. And so on that direction. And then negative 1's absolute value is positive 1. And negative 2's absolute value is positive 2. Let's see if I can put me right. Okay, my domain and range are going to be the same as my quadratic for this one. I can continue to go forever and ever and ever on my x-axis. I can plug any x value into that absolute value. But it's always going to give me a positive answer for my parent function. So I'm going to start right there touching 0 and go up to infinity. All right, let's jump from there to our cubic function. So x cubed. X cubed is also going to start at 0, 0, but remember this time we're going to cube our x values. So our graph's going to get bigger faster as we are positive. So positive 1 cubed is 1, and positive 2 cubed is 8. So I'm going to jump all the way up here to 8. Now the big difference on this one is on the other side, because when I cube a negative value, it's still going to be negative. So I'm going to go negative 1 cubed is negative 1, and negative 2 cubed is negative 8. Okay, so this one's domain and range are going to change a lot. So I can still plug in any x value to this function. So I'm going to say that my domain is still all real numbers. But in this case, I could go up and up and up forever. I could go down and down and down forever. And so I also have a range of all real numbers. And even as we do transformations to this graph, that domain and range is going to stay the same. These will change a little bit, but this one's domain and range stays the same. And again, I drew 5 points on that graph. So it just kind of gives you an idea of how many points I want to see on all of your graphs as we go through. Okay, another parent function you're probably familiar with is our radical, so our square root graph. Let's look at a square root. Okay, this one's a little bit different because we can't plug negative numbers into this function and get back a real number that we would be able to graph. So I'm still going to start at 0, 0 on this one. Now this time I'm taking the square root, so I'm going to go over 1 and say the square root of 1 is 1. But then I'm going to go all the way over to 4 on my x-axis because the square root of 4 is 2. And so rather than trying to take the square root of 2 in my head and guesstimate a point, I'm going to go all the way over here to 4. So you can see 4 on my x-axis. And that's going to take the square root of 4 is going to give me a y value of 2. So our graph here looks a little bit like this. Okay, again, I don't go on my negative x-axis because a negative value inside your square root would give you an imaginary answer. So a square root graph is only going to end up giving you 3 points, or we only need to graph 3 points when we're talking about a square root graph. Okay, another thing that's pretty different on this one is that our domain is not going to be all real numbers. Again, I can't plug in those negative x values. I can only plug in positive numbers and 0. So I'm going to start at 0 and go up to infinity. And then same thing for my range on this one. Before we do any transformations, I'm just starting everything right there at 0 and getting positive values back. Okay, my last parent function that I want to spend some time on just a little bit right now is going to be my rational graph, which looks a little bit like that. I'm not going to spend a lot of time on that right now. We're going to come back to that in a couple of weeks and spend some more time on it. But this rational graph has some issues as well. And those issues include when we are talking about having 0 in a denominator. We can't have 0 in a denominator, and so what that does is it gives us a vertical asymptote right here on the y-axis, or where x is equal to 0. This one's also going to have a horizontal asymptote. Some of them do. Some of them have a slant asymptote. Okay, but we end up with these little asymptote things. Remember that asymptotes are special because we cannot touch or cross them when we're talking about these parent functions. We'll talk about some special situations in a couple of weeks, but for parent functions, no touching or crossing these. I really just want to see 1 point. I'm going to go to 1, and if I divide 1 by 1, I get 1, so I'm just going to go right there, and I'm going to draw close to my asymptote without touching or crossing it, and same thing this way. And then if I divide 1 by negative 1, I get negative 1 over here. So I'm just going to look for those 2 points right there, kind of in the corners of your asymptotes for these basic ones. Okay, so on this one, I want to see 2 asymptotes. I'm going to abbreviate that like that, and 2 points. Okay, so for your rational graphs, 2 asymptotes and 2 points will be plenty for those. Okay, these have funny domain and range. Again, we weren't able, as we were coming across x, we weren't able to include 0, but we can go right up to 0 without touching it. So remember, when we talk about not being able to touch a number, we talk about using parentheses, and then I'm going to start back at 0 and go up to infinity that way. And then my range is going to be the same. Kind of ran out of room on that one. Okay, so we can use decimal numbers that approach right up to that 0, but we just can't touch 0. So no bracket on those, just use parentheses. Okay, so let me take just a second on a piece of paper and just write down the basic transformation rules for you. And then we'll take a look at a couple of transformations. Let's start by looking at what happens if we multiply in the front by a negative. And what that's going to do to my function is that's going to make it reflect over the x-axis. That's going to flip it upside down. Okay, so what that's going to look like when you're drawing is if you said that you were going to go to the right one and up one, instead of going up, you'll go down one. So you'll go right one, down one instead. So it just kind of flips those up and down directions around. Just to give you a little bit of an example, I'm going to use the function x squared. So that would look like this. Okay, we'll take a look in a minute at some graphs and get some practice with these. Okay, let's see here. The next thing I want to look at is what happens if you multiply by a whole number. I'm going to use that little symbol right there for a whole number. So hashtag also means whole number, or number. Okay, if I multiply by a whole number out front, that's going to cause a vertical stretch. Okay, that's a little bit like this. Okay, so there's my whole number out front. That 2 right there is going to be my whole number. So what's going to happen there is if you said that you were going to go, let's say, right one and up one, instead of going right one up one, you would go right one up 2. So I'd multiply that value by 2. Or if I said I was going to go right 2 up 4, I would go right 2 up 8. So I'm going to take that vertical amount, positive or negative, and I'm going to multiply that by 2. Okay, very similarly, if I multiply by a fraction, that's going to cause a vertical shrink. And that looks like this. Okay, and same thing, that's just going to affect the vertical number. So if I was going over 2 up 4, I would go over 2 up 2. So I take half of that vertical number. Okay, let's say I have something added or subtracted on the inside of my function. I'll show you what inside means here in just a minute. So these are kind of opposite from what you would think. An add is going to make you move to the left, and a subtract is going to make you move to the right. It'll look a little bit like this. Okay, so opposite from what you would think. So in that case, I would take my quadratic and I would move it to the right 2 units. And the way that I like to look at that is I like to move my 0, 0 point to the right 2, and then still build my same graph off of that right 2. And again, I'll show you some examples of that here in just a minute. Okay, and finally, we have add or subtract on the outside. And these tend to go in the direction you would think. So an add makes you move up, and a subtract makes you move down. And that will look a little bit like this. I'll have my x squared first, and then I could, let's say, add 3. So that right there would make me move up 3. Okay, so I'm just going to look at 2 examples of graphs or parent function graphs that have transformations with them. So back over here to my graph paper. Let's take a look at that quadratic, and let's take a look at x minus 4 squared plus 3. Okay, this one's a quadratic, so I want to draw 5 points. Let's find out first where we're going. I don't have anything happening up here in the front, so I don't have to worry about a reflect or a stretch or a shrink. The first thing I have happening is this minus 4 on the inside. So the minus 4 is going to make this thing move to the right 4 units. And then the other thing I have happening here is this plus 3. So that plus 3 is going to make this graph move up 3 units. Okay, and again, like I said, I like to move my 0, 0 point and then build my graph off of that. So I'm going to take my 0, 0 point and I'm going to move it to the right 4 and up 3. So 1, 2, 3, 4, and up 1, 2, 3. Okay, and now for my quadratic graph, I'm going to go over 1, up 1, and over 2, up 4. 1, 2, 3, 4. These little boxes all kind of run together. And then I'm going to go to the left one, up 1, and to the left 2, up 4. 1, 2, and then 1, 2, 3, 4. And there's my parabola. Okay, so that move did not change my domain. I can still plug in any x value to that. I can still go all the way to the right and all the way to the left with this graph. But it did change my range. Notice now that my lowest y value is 3. So I'm going to say that this range is now from 3 to infinity. So with your parabolas, your range is what's going to change when you start moving left and right, or up and down, or reflecting. Okay, let's do one more example, and then I'm going to leave you with the rest of this graph paper for when we do some other examples, or if you need some extra help come to tutoring, you'll have some extra graph papers that you can work on. Okay, let's take a look at a reflection with a stretch. So let's look at what happens with some of these things out front. I'm going to go ahead and also do a vertical move. Okay, let me go down here and write down what's going on here. So the negative out front is going to make me reflect. So rather than going up, I'm going to be going down. Okay, the 2 in the front is causing the vertical stretch. And the minus 3 over there on the end is going to make this thing move down 3. Okay, so the only thing that my 0, 0 point is going to be affected by is this down 3 in here. So I'm going to take my 0, 0 point, I'm going to move down 1, 2, 3. So that's going to be kind of my new starting point. Okay, now I'm going to do two things at the same time. So normally for an absolute value, I would go over 1, up 1. But because of the reflect, I'm going to go down. And because of the vertical stretch, I'm going to go down 2. So I'm going to go over 1, down 2. And again, normally I would go over 2, up 2. But instead, I'm going to go over 2, down 4. And then I'm going to do the same thing on the other side. Normally I would go negative 1, up 1. So I'm going to go negative 1 and down 2. And I'm going to go negative 2 and down 4. Put some arrows on the ends, it kind of keeps going. Okay, so very much like my parabola, none of that's going to affect the domain. I can still plug in any x value into that function and come out with a y value. Now this one is going to look really funny on the range. If I think about my y values, this one's going down and down and down forever, so I'm going to start at negative infinity. And then I'm going to say that it goes up to negative 3 right there. And that's where it stops, and it is touching negative 3. So sometimes with those reflect questions, you get some funny range answers in there because you're talking about negative infinity. So watch out for those. Okay, so give the problems on the worksheet a try, and I'll see you next time.